This is section 5.6, graphs of other trigonometric functions. And we're going to begin with graphing the secant and the cosecant functions. Let's remember our definition of a cosecant. Y equal to the cosecant of x is equal to the reciprocal of the sine function, 1 divided by the sine of x. So, where the sine of x is equal to 0, in other words, the x-intercepts of the sine of x become the vertical asymptotes of the cosecant of x. So let's take a look at this table here. Where the sine of x is equal to 0, we now have the cosecant of x undefined. That's because this is 1 divided by the sine of x. So these are all of the vertical asymptotes on the cosecant of x. This gray graph here, this is y equal to the sine of x. So if you note that y equal to the sine of x has a 0 at negative pi, 0, pi, and so forth, 2 pi. What do you notice? That's where the cosecant of x has vertical asymptotes. Okay? So the max and the min from the sine function correspond to the min and the max for the cosecant function. Okay, so those are interchanged. What used to be a max on the sine of x is now a minimum on the cosecant of x. Okay, so it's very nice. Let's take a look at y equal to the secant of x. Again, we have that the secant of x is 1 divided by the cosine of x. So if this gray graph is y equal to the cosine of x, all of the zeros, or the x-intercepts of the cosine of x, now become the vertical asymptotes of the secant of x. Okay? And likewise, as you can see, where the cosine is equal to 0, the secant is undefined. So this is where we will have our vertical asymptotes. Okay? The graphs, let's just look at a quick summary. There is a period of 2 pi for both of these. There is no amplitude. As you can see, these graphs grow without bound. We have the origin as our sine function is an odd function, so the cosecant is an odd function, and the cosine is an even function, so the secant is also an even function. Okay, so we're symmetric with respect to the origin, and we're symmetric with respect to the y-axis. Okay, so let's go ahead and try to graph this first one, y equals -2 cosecant of 3x. Right away, you can see that we are going to reflect the cosecant of 3x across the x-axis. So that's going to be important to start with. Let's go ahead and take a look at the amplitude. That's the absolute value of -2, so that's equal to 2. The period, again, we'll take 2 pi and divide it by b, which is 3. So we will have one complete cycle between 0 and 2 pi over 3. Okay, let's talk about where y equal to 3 sine x has x-intercepts. Let's do that first. Note, y equal to the not the secant, the sine of 3x has x-intercepts at even multiples of pi over 3. So what does that mean we have for the cosecant graph? We have, therefore, y equal to the cosecant of 3x has vertical asymptotes. Let me write that on the millimeter. At those same places, at even multiples of pi over 3. Let's go ahead and take a look at those. So as you can see, I'll use maybe a highlighter this time. Take a look at that. Pi over 3, negative pi over 3. And as you can see, we have zeros on the graph that are now vertical asymptotes for the cosecant. So it's very nice, I believe. You can see the amplitude of 2 here. And you can see one complete cycle between 0 and 2 pi over 3. There's one complete cycle. Okay, so now let's go ahead and we could just go ahead and write down how we would use this period of 2 pi over 3. How would we use that? We can just do a couple of these. So the first thing we would do is we would take 1/4 of 2 pi over 3, and we would get pi over 6. And that's not our number 1. So now what would we do with that? We would first start at 0 and add pi over 6. And we would get a point of pi over 6, negative 2. Okay, so we reflect it across the x-axis. There's the reflection, and there's the amplitude. Okay, and there it is right there, that point. Okay, we can do the second one. We don't have to do all of them. We'll have 0 plus 2 pi over 6's, and that's equal to pi over 3. And that generates a point, as you can see, that is at a vertical asymptote. Okay, then we'll go ahead and go to 3. 0 plus 3 pi over 6, and that will be, put vertical asymptote there, pi over 2, and that generates a point, pi over 2, 2. And as you can see, that's right here. And that would continue on. Okay, so let's take a look at the next graph. What's the difference between this graph and this graph? You guessed it, right here. We are going to add 1. We have a vertical shift up 1. So we will add 1 to the y values of the graph in part A. So let's do a few of those points. Pi over 6, negative 2 now becomes pi over 2, negative 1. As you can see right here, pi over 2, negative 1. Then, if we have, that would be pi over 6, negative 1. And you can see it right here. And then let's take our next point, pi over 6, 2. We would have now, that's pi over 2, 2, my goodness. We will have pi over 2, 3. And as you can see, we're at pi over 2, and we're right here at 3. Okay, so I'll put that point there, and I'll put that point there. Goodness. Okay, so now let's talk about the tangent and the cotangent functions. We'll use that same concept of where we have an x-intercept for the sine of x is where we are going to now have our multiples of pi. So as you can see right here, this is y equal to the tangent of x, okay? So where the sine of x is equal to 0, that puts 0 in the numerator. And that is why when the sine of x is 0, we have an x-intercept on the tangent of graph, okay? Now, how about a vertical asymptote? We have a vertical asymptote where the cosine of x is equal to 0 because it's in the denominator. And that is where the cosine is 0. So this is a very nicely graphed function. As you can see, we do have an odd function because it's symmetric with respect to the origin. Each quadrant, one point, has a mirror image in quadrant 3. This is actually a feature of being an odd function. And the period of the tangent function is pi. So one complete period occurs between two consecutive vertical asymptotes. So what we're saying is we have right there from pi over 2 to 3 pi over 2, we have one period. We have one complete cycle. So now let's look at the reciprocal of the tangent of x, and that's the cotangent of x. And these same concepts apply. Where the cosine of x is equal to 0, that is where we will have our x-intercepts. Where the sine of x is equal to 0, we will have vertical asymptotes, okay? And you can see that graph here. We still have an odd function, symmetric with respect to the origin, mirror image in quadrant 3, and the period is still pi. Each one of these is a distance of pi, and so forth. Okay, so now let's look at this summary. As you can see, we have a period of pi, and we have odd function, and you can see the vertical asymptotes, multiples of pi over 2, and then also multiples of pi. And these are odd multiples. Okay, when graphing, again, we still have our period is pi over b. The vertical shift is d, phase shift c over b. And then we will have two consecutive vertical asymptotes and between those, and we will be solving these inequalities for each one of these graphs, one for the tan and one for the costan, okay? So we will always have an x-intercept halfway between the asymptotes, okay? So let's go ahead and try to graph y equal to the cosine of 4x. Remember, we will have our period, and that's pi divided by b, and in this case, that's 4. Okay, so we have one cycle, one complete cycle, I wanted to say. In each period of pi over 4. So now, and you can see that right here. And so now we could look at this midpoint, and let's talk about the x-intercepts at these midpoints. So we'll take 0 plus pi over 4 and divide by 2, and that comes out to be pi over 8. And that is an x-intercept right here. And you could do that on each interval. Okay, let's take a look at this next graph. Y equals 4 times the tangent of 2x plus pi over 3. When we have these additions in there, it can be a little bit tricky. So we're going to go ahead and write this out. We have negative pi over 2, and then we have 2x plus pi over 3 in between negative pi over 2 and pi over 2. Okay, so now let's subtract pi over 3 from every part of this 3-part inequality. And we come up with negative 5 pi over 6 and pi over 6. And then dividing each part by 2. And so we have one complete cycle between negative 5 pi over 6 and pi over 12. And you can see that right here between pi over 12 and negative 5, and that should be 12 right here. Okay, and another one there. So all of those are vertical asymptotes, and you can see where we have one complete cycle. We could also find those x-intercepts. Let's try that. Our x-intercepts are at our midpoint of those vertical asymptotes. So negative 5 pi over 12 plus pi over 12, all divided by 2. And we will get negative 4 pi over 12, all divided by 2. And if you do that, we will have, we can multiply by a half. And so that is not written very good, is it? I'll try to write a little neater. And maybe I could bring this over here and then just write across. So now this is equal to negative 4 pi over 12, all divided by 2. Negative 4 pi over 12 divided by 2 is multiplied by 1. Dividing by 2 is the same as multiplying by 1/2. So we would actually have, and then that 12 and that 2 can cancel. And we would have a negative pi over 6. And these are our x-intercepts. Okay, negative pi over 6. And we get pi over 3. We could do that for each interval between the vertical asymptotes. Okay, and now in number 4, it is not the same graph, but we still have a tangent graph. And the very first thing you should notice is we have a reflection across the x-axis. Okay, so what do we normally have for the tangent of x is now going to be looking like this. This is the opposite of the tangent of x. Maybe I better put y equals so you know that that dash, that negative sign is there and it's not a dash. So this is the reflection. And as you can see, we will go up 2, a vertical shift going up 2. And let's go ahead and put that interval in between negative pi over 2 and pi over 2. So now multiply everything by 4. And then dividing by 3. I think I forgot an x in here. And then we're dividing everything by 3 pi. And we'll have negative 2/3 is less than x, less than 2/3. And so, as you can see right here, we have negative 2/3 and 2/3. Okay, so we have one complete cycle. There. And let's go ahead and see if we can come up with our x-intercept. And we could do that before we move up 2 units. So before moving up, before shifting up 2, here's how we will find our x-intercepts. And we'll just find one of them. So we'll take the midpoint of negative 2/3 and add that to 2/3 and divide that by 2, but that's equal to 0. So that is why we have this 0, 0. So here we will move up 2 units for the graph of this function with the +2. Okay, and that completes this section.